Hey guys, so this section we're talking about radians. So I have up here the section with the notes that kind of explains radians. So a radian is just a measure. It's using the radius, which is why it's called a radian, to measure angles. And it's just a different way to write things using pi. So we're going to do kind of a video within a video here to show you how a radian works. So I take the radius of a circle, and we're going to take that radius and move it out and go along the arc. And that arc length makes an angle, which we call a radian measure. So if you go halfway through a circle, we have pi radians, so that's 180 degrees, and all the way around 360 is 2 pi radians. Okay, so we're going to measure radians, and if you look at your notes, you might want to just really be familiar with these. You're going to have to just write them down for your test. So 30 degrees is pi over 6. 60 degrees, pi over 3. 45 degrees, pi over 4. Half is pi over 2, it's 90 degrees, and then like we saw in the video, all the way to 180 is just pi. Okay, so this is the main formula you're going to have to know, is the arc length is pi times the radians, or not pi, sorry, theta times r. So theta is radians, r is the radius. So let's look at some self-checks. Identify the radian angle measure for the angle shown below. So the angle that we're looking at is this angle. It goes all the way around the circle. So I know that half right here is pi. And then I know that this quarter is pi halves. And I'm getting that from this. A 90 degree angle is pi halves. A 180 degree is pi. And we're looking at this leftover angle. So you have to recognize that this is 30 degrees. So if that's 30, this would be 60 degrees. And 60 degrees is pi over 3. So I have to add these 3, and you'll get to the point where you'll probably just know what that is, but we're going to add them. And I'm going to write pi as pi over 1. So we have to use our fraction rules here, guys, so I need a common denominator. I have 1, 2, and 3, so my common denominator is going to be 6. So I'm going to times this by 6, this by 3, this by 3. So I have 6 pi plus 3 pi plus 2 pi all over 6. So 6 plus 3 plus 2 is 11. And then pi is kind of like x. This pi just comes along and we write it just one time. And then the denominator stays the same. So we have 11 pi 6 is that angle in radians. Kind of different, but you'll get used to it. All right, the distance from the sun to the Earth is this really long number, kilometers. Assuming the Earth has a circular orbit around the sun, and then it tells us, be noted, that planets actually have elliptical orbits, not circular. But we're assuming it's circular. Find the distance the Earth travels in orbiting the sun through an angle of 3.19 radians. So this is one we're using this formula. So arc length is theta times r. Theta is radians. R is radius. So think about what's happening. We have Earth. Sun. Beautiful artwork. And we're going around. So this distance, the 1,496, 1, 2, 3, 4, 5. Yep, that's our radius of the circle. And then the 3.19 radians, that's gonna go here. Okay, so what we're doing is we're multiplying these numbers. I'm gonna take 3.19 times this number for r. So here's Desmos. 1,496, 1, 2, 3, 4, 5 times times 3.19. So 4722400. So this would be the distance the Earth travels all the way around. Okay? So when you have a problem like this, multiply. That's the point. Multiply those numbers. Okay? All right. Identify the radian angle measure. Move these back. So this goes back to you're probably going to have to reference these or write them down, guys. Okay, so we know that a 90-degree angle, this is pi over 2 radians, pi halves. And then you have to recognize that this angle is half of 90. It's 45 degrees, which is, we say this, pi force. So this is pi over 4. So if we want to find this angle in radians, we're going to add these two. We're going to do what we did on the first problem. We're going to get a common denominator, which is 4. So I have to multiply both of these by 2. So 2 and when we add, we keep the denominator and the numerator. We have 1. Remember, there's an invisible 1 next to everything. This is 1 pi plus 2 pi, which is 3. And then the pi is 3 pi force. That's the radian measure. Determine the radius of a circle whose arc length measures 49.4 meters and central angle is 1.25 radians. So we're going back to this formula, arc length times r. Theta is radians. And r is radius. So let's look at what we're given. We're given an arc length, 49.4. That goes here. And then we're given our angle measure in radians, 1.25. That goes here. Oops. And then we're trying to determine the radius. So we're trying to figure out what r is. So we're going to set up an equation. 49.4 equals 1.25. We're solving for r. So now it's just an equation. The opposite of multiply is divide. So we're going to divide both sides by 1.25. 49.4. That's what it was. Yep, divided by 1.25, which is 39.52. And we're going to round up to 40. Okay, so one more. Find the arc length on a circle with radius 17 and angle of 2 pi thirds. So arc length equals theta times r, where theta is radians and r is radius. And we're trying to find the arc length. So I have 2 pi over 3 times 7. So when we multiply straight across. So I have 2 times 17, which is 34, and then the pi just comes along. And then 3 times 1, which is 3. There we go. So that's it for this section. I would really say write these down, be familiar with these. You're going to need them in the next section as well.